In this next video here, we're actually going to be going backwards from the types of problems that we've been looking at. So if you look back at the very first example that we did, we started with a graph and then we wanted to talk about what is the limit at various x values. Here I'm going to start with some properties about the graph, and I'm going to see if I can generate a graph that meets those properties. I really like these types of questions. I think they require a very deep understanding of limits and of functions. So these are questions that I do often like to include on quizzes and exams. I think they're really good questions to study. So here in this first example, I have f of 1 is equal to -2, limit as x approaches 1 from the left-hand side of f of x equals 2, and the limit as x approaches 1 from the right-hand side of f of x is equal to -2. And I'm just going to start at the top here. F of 1 equals -2. We'll do this guy here in blue. F of 1 is equal to -2. Essentially, that's just giving me the coordinates of a point that's on my graph. It's saying I have a point at 1, -2. And as soon as you plot that point, we're done with that property. That's it. So let's change our color here. Now let's look at the left-handed limit right here. We'll do that part in red. This says the limit as x approaches 1 from the left-hand side of f of x is equal to +2. So here's the left-hand side of 2, right? All of this that I'm just shading in is the left-hand side of 1, excuse me. And this says if I approach from that left-hand side, so if I get closer and closer and closer to 1, I need to end up at a y value of 2. So I need to end up at this point right here. Now, how you do that is up to you. You can make it a curved line. You can say, oh, this right now has met that property. You could just make it a straight line if you wanted to. You could make it a cool oscillating function, right? A trig function, something like that. Generally, my advice to students, if they're a little bit unsure about these types of problems, is to keep it simple. One thing that I will notice sometimes, I'll see students that try to get too fancy and they say, okay, I'm going to draw something that looks like this. But the problem is, okay, you've met this property, but it's no longer a function because it fails the vertical line test right there. It intersects here, here, and here. So you've met the property, but you actually haven't given me a function. So again, my advice, just keep it simple here. You know, make it a line or a parabola or something like that. I usually just stick with lines. And I've met that criteria. Although, one thing I should note here is that this is also not a function because it's going to intersect, if I drew a vertical line at 1, it would intersect here and here. So how do I fix this now? Well, I know that my function needs to be defined. That first bullet point, right? F of 1 is equal to -2. That's what told me that I have this point right here. So that I know has to be a closed circle. And in order for this to be a function, I cannot have a closed circle at anywhere else for an x value of 1. So how do I fix that? Well, if it's not a closed circle, it's probably got to be an open circle. Whoops. So let me see if I can just erase that point. There we go. And I'm just going to put an open circle right there to denote that there's a hole there. So it still satisfies this limit. If I get closer and closer to 1 from that left-hand side, I'm still going to get closer to a y value of 2. But now I've solved the problem of this not being a function. The last bullet point right here, limit as x approaches 1 from the right-hand side is equal to -2. So everything over here on this side is the right-hand side of 1. I just need to end up at a y value of -2 here. So here in this case, how you want to do that again is kind of up to you. Again, my advice is just to keep it simple. Make it a line, make it a parabola, something like that. So at this point, I've met all 3 of my properties. I'm done with this. So this graph is actually my answer. This is a graph that meets all of my criteria. Now, what's interesting about these problems is that everybody's graphs might look just a little bit different, right? How you approach from both the left and the right-hand side might differ, but the actual values of the left and the right-hand limits should always be the same, regardless of what I'm looking at. I should always end up with a left-handed limit of 2 here in this case. So let's look at one more here. Here I want to again sketch the graph of a function with the following properties. And again, they've given me 3 points to start off with. So let me plot those in blue. First one says I have a point at 1, 0, so I'm going to graph that. I have a point at 2, 4, so let's see, 1, 2, 3, 4 right here. And then I have another point at 3, 6. And actually, as I'm looking at it, I don't have enough tick marks right there. So let's just add one more. So 3, 6. Oops. I should have a point right about here. So again, those are just giving me 3 ordered pairs. So I'm done with those. Now I need to talk about the left and the right hand limits at 2. So let's do the first one in red here. So let's look at the left-handed limit first. This says the limit as x approaches 2 from the left-hand side of f of x should equal -3. So I should end up at a y value of 3 right here. Now I've put a closed circle. Be careful here. Remember that we already had this closed circle right here at x equals 2. So that means I can't have another closed circle down here. I'm going to fix that the same way I did in the last problem. I'm going to put an open circle right there. And how the left-hand side of your graph looks is up to you, but this time we have a little bit more structure. We know that it's going to pass through this point right here. And you could get really, really fancy with these, but again, my advice is just to keep it simple. I'm going to draw a function that passes through this point and then ends up at this red open circle that I've drawn. So again, if you just want to draw a straight line, that's not a particularly good straight line, but it meets the criteria, it fits the bill. You could draw a parabola of sorts, as long as it passes through that point 1, 0 and ends up at this red open circle at 2, -3. I've met this criteria, so that's good. Let's do our last property in blue here. We want to look at the right-sided limit here. So the limit as x approaches 2 from the right-hand side of f of x should be 5. So I'm talking about this point right here. Again, this time I drew an open circle right from the get-go because I already know that I have this closed circle right here. In order to be a function, it can only be defined at one particular point for this x equals 2 in this case. And again, however you want to approach it is up to you, as long as we pass through this point right here and end up at this open circle right there. So maybe we'll just draw a straight line, something like that. Oops, it doesn't quite pass through that point. Let's go ahead and fix that. Something perhaps that looks like this here. And at this point, I've met my third criteria, so this graph is my answer. Now your graph, if you're comparing answers with a friend or you're checking your answer, your graph again might look a little bit different than the graphs that are in the book or the graphs that your friend might have, but the behavior at x equals 2 and then these 3 points right here, those should all be the same regardless of what the rest of your graph looks like.